So here we want to set up the partial fractions for the decomposition of this rational expression, but we're not going to solve for it. It's going to be take too long and too big of a thing to solve for, but on a test, but we can show what they would be to show that we understand the setup. Looks like there's an extra parenthesis in there. Ignore that. All right, so if we're going to set up the partial fractions, we have 5x to the fourth minus 4x to the third plus 228x squared minus 27, and that's over x minus 4 to the third and x squared plus 3 squared. So we have linear factor and quadratic factor, and they're both repeated. The x minus 4 is repeated 3 times, and the x squared plus 3 is repeated twice. So we're going to need a fraction for the x minus 4 to the third, and we need one for each lower power. So we need an x minus 4 to the second. That 3 looked a little big. Let's make that a little bit smaller. Okay, and then we need another one, so c over just the first power. So that is the pieces for our linear x cubed. Now we've got a quadratic, and that's twice. So the first one is going to be x squared plus 3 squared, and the numerator needs an x term and a constant, so dx plus e, and then we need one for the lower power, so just the x squared plus 3, and so we would have fx plus g. So those we would have 1, 2, 3, 4, 5, 6, 7 equations and 7 variables, so we're not going to solve that, but we just wanted to show and make sure you could show how you would set it up.